Tell you what tells me how attendance you were. Your test results help a lot in telling me. All right, cam, follower, where? How does that affect our spark? All right, so it makes it happen a little bit later, and then that means it won't be at E gap, so that means it will be weaker. There we go. Where isn't likely to make things hotter and better. All right, moving along. Why are there two lights on the magneto-timing box? Well, this is something that we use on the ground. So do we need a backup? How do we know when the point's open? Okay, so to indicate when the point's open and when they close, this is a common misunderstanding. I've got a light in my bedroom here. Do I need two lights to tell me if the switch is on or off? Or can I tell with just one light bulb? Just one light bulb will tell me very clearly whether my switch is on or off. Now, these ones are a little weird. The way they work, it's on when the switch is open and off when the switch is closed, but that's just a wiring thing. You only need one light bulb to tell you if a switch is open or closed, if you're at all smart, right? Off, points are closed. On, points are open. We have two lights because we have two magnetos. Oh, painted red tooth. I didn't talk about this too much. We use this painted red tooth to help set up our ignition timing when we do the external timing, when we time the magneto to the engine. So what position do we want to set the magneto in before we bolt it to the engine? That's the point that the red tooth will tell us that we're in. We want to be at E gap on engine number one, on position number one. Very good. When the point's open, right. The magneto timing light, that light, that buzz box, is connected to the breaker points. It doesn't know when we're at neutral. It doesn't know when we're at E gap. It doesn't know anything else except for when the points open and when they close. That's what it's connected to. Sorry, I skipped there. Probably shouldn't have. To make sure that the spark happens at the right time. How do we set the breaker points are opening at the right time? That's what we call internal timing. And that's what you do with that little pointer on the magneto, and you set it so that 10 degrees after neutral, the breaker point's open. But that's not timing the magneto to the engine. That's called internal timing. Internal timing is when the breaker point's open at the right time. I guess I could sort of see you maybe be getting fooled by this wording. But thankfully, most people got one of those two at least picked. All right. All right, if this bongos us out before we finish, I will send you guys, I'll click through it so you'll get the podium thing. Rotate the magneto on its mount. Vernier coupling, that's base mounted magnetos, that's old radials. Adjusting the points, that's done before you put the magneto onto the engine. And rotating the crankshaft slightly won't change the relationship of the magneto to the engine timing. You actually twist the magneto on its mount. And we'll show you that on Friday. The gears is course timing, correct. And I'll show you that in the shop as well. Right. Now, all of these would be right, except that we don't do it on aircraft ignition systems because they're so simple and basic and crude. We just set it to one position, 25 degrees port top dead center, and take the compromise. So it's not going to be right at high RPM. It's not going to be quite right at low RPM. It's just a kind of sort of good number that we put it at. We should advance it to allow more time for the combustion event. We should retard it to reduce detonation if we have detonation. We would get lower cylinder head temperatures if we advanced it because the engine runs more efficiently. But seeing as these are old tractor engines, we do not. We should. If you picked red, you're understanding what we should do. If you pick green, you understand why we don't, what we actually do. Most cars, all cars, have got variable ignition timing. So they'll run around 8 degrees before top dead center at idle, 25 at cruise, 30 or 40 at really high RPMs. Our aircraft engines don't do that, but they should. So kind of a trick question, but that won't be on your test. The answer to the last one is we don't. We should, but we don't. Aircraft do not advance the timing. They run fixed. Base-mounted magneto. Compensated cam is on a base-mounted magneto, and this is a tough one, and that would be on a radial engine. Mr. Tessier loved this question because it was asking two things at once. Base-mounted magneto is on a radial engine, and radial engines use compensated cam. You want to know that radial engines use compensated cams. All right, make a note of that. I think we might bongo out here any minute. It hasn't given me a warning, but just trying to move things through here. I hope I'm not. All right, so we don't get a hot spark with a magneto because it's spinning too slowly. The normal spark doesn't happen too late for starting. It happens too early for starting. We will get kickback. The engine is cold. Well, we've got a fuel issue, but not a spark issue. And battery power doesn't have anything to do with this. Remember, our magnetos don't make a spark off of battery power. They make a spark off of engine rotation. What's the source of power? Engine rotation. Engine spinning slowly, not much power. Yeah, not to make a hot start. Sparks happen very quickly. We don't need the time for a spark to build. We don't want the engine to kick back. Remember, the piston's coming up, and normally that's an okay time to fire the spark. But if it's running really slowly, it might just push backwards. Ah, this is one of the tougher questions. Almost to the point, just memorize the words. See how you do, and then I'll give you the answer. They conduct the pulse DC away from the coils. Remember that pulse DC does not want to go through the coils. If we allow that pulse DC a path, it will avoid the coil. The collapse of the magnetic field in this case is happening much differently. It's happening because of the pulses in the DC. So I'm going to skim over this and we'll talk about it a little bit more tomorrow because I know this is a tough concept. Oh, I didn't talk about this. Booster magnetos. How did I skip that? Booster magnetos use trailing fingers. It's an old radial engine trick, and you want to know that for Friday. Booster and magnetos are used on radial engines, and they use a trailing finger to delay the spark. And I'll show you a picture of that tomorrow. Retard points be tested. Yes, there's a question similar to that one on the test. And I will go over that system again tomorrow, Braden. That's a tough one for everybody. Actually, it was tough for me when I first learned it. So that means it must have been really, really tough. Oh, look at this. I think we might finish this Kahoot before we got to go. Engine won't start. If that impulse coupling is gummed up, the little fingers won't stick out and catch on the little pins, and it will just sit there spinning like a regular magneto, and the engine will never make a spark and it won't start. Maybe if you got it fast enough, you might get a kickback out of it, but it's not even gonna, probably not even gonna do that. Seems to be giving me a bonus 5 minutes here. That's good. Number 2. Okay, this should be easy. Number 1 connects to 1. number 2 terminal connects to 6. Number 3 terminal connects to 3. That's easy. Number 4 terminal connects to number 2. See that? 1, 6, 3, 2. So 1, 2, 3, 4. And it doesn't matter if it's the left or right magneto. Firing order is the same. Number 4 terminal connects to the number 2 spark plug. And that can be really important if you're dealing with a car that doesn't have marked leads and you took them all off and you got to try and put them back on. The shower of sparks, that's that fancy one with all the wires and stuff going on it. What was the power source in that one? The battery, yes. And if it's dead, we won't start. But that's okay. We just won't go flying. All right, the engine turns, and what does it do? It winds up a what was the last answer? Power source in a shower of sparks is the battery. Was that your question, Isaac? I think so. And then the power source in an impulse coupling is we wind up a spring and it releases. We're going to do this again tomorrow. Don't worry, Isaac. I'm just trying to. The vibrator puts out a pulsed DC current. And when we force a pulsed DC current through a coil, we get a whole lot of sparks. We get a shower of sparks, in fact, when we force pulsed DC power through. And it's low voltage. It's only 24 volts straight off the battery. Okay, and I did rush that one, but the wound up spring. The engine is the initial power source, but then it winds up a spring. And then that wound up spring releases energy in a spark. All right, last question. Sorry, I'm rushing because I want to make sure the clock doesn't tick out on us here. All right, to make and I wrote this down. I wrote that down at the beginning. I said to create a hot, late spark. We need to make it late so the engine doesn't kick back. We need to make it hot because it's moving too slowly. All right, let's see how you folks did here. 14, that's not too bad. 75%. 80%. All right, we'll hit this again tomorrow.